Hello, sixth graders. Today we are going to be working on lesson 6-3, which you're going to find in your workbook on page 347. And this lesson is entitled Representing Percents Greater than 100 or Less than 1. So before we jump into this lesson, I do want to do just a quick overview on what we've gone over so far in lesson 6-1 and 6-2, which is writing percents as fractions and decimals, and also as percents. So if we were to have a number that was a percent less than 100%, let's say we had 60%. Let's say we're going to start with 60%. Okay, so we all have worked with 60% as a fraction at this point, so we know that 60% as a fraction is going to equal 60 over 100, which then as a decimal is also going to equal 60 hundredths, right? 60 out of 100, 60 hundredths, which is 0.60. So this is the basic gist of what we've been doing over the last two lessons, is that a percent can be represented this way as a percent with a percent sign. It can be represented as a fraction over 100, and it can also be represented as a decimal that terminates in the hundredths place. Well, it can go farther than the hundredths place, but then, so let me give you an example. So if we had 6 to 1, so if we terminated our number in the thousandths place, that just means that this would equal 62.1%. So I shouldn't say that it has to terminate in the hundredths place, but your final digit of the percent as a whole number is going to be in the hundredths place. Okay, so we know that 60% equals 60 over 100, which equals 0.60. And what we're going to be talking about more today is how we can write percent. So let's say we had, we were talking about the percent of time we spend doing schoolwork in a day. So let's say we had a really busy day, and let me see if I can make this font a little bit bigger. So let's say we had a really busy day and we were spending 6 hours out of 24. So 6 out of 24 hours we were spending on schoolwork. And we wanted to write that as a percent. So I'm looking at this and I'm thinking to myself, uh-oh, 24 doesn't go very nicely into 100%. But here's something I can do. I can look at 6 over 24 and I can say, well, 24 doesn't go very nicely into 100, but I think I can reduce this fraction to make something that would go more nicely into 100. So what's the greatest common factor of 6 and 24? The GCFs of 6 and 24 is 6 itself. 6 goes into 6 once, and 6 goes into 24 4 times. So I go 6 divided by 6 equals 1, and I'd go 24 divided by 6 equals 4. Now I have a fraction 1 over 4 that goes much more nicely into a fraction over 100. So now I can multiply 1. Well, I'll start on the denominator. So how would I get from 4 to 100? I would multiply by 25. So 4 times 25 equals 100. So 1 I must also multiply by 25. So 1/4 equals 25 over 100, which equals, then we all know, at the end of the day will give us 25%. I almost said 100%. 25%. Okay, so 25 over 100 equals 25%. So even if we have a number that we're starting with and we're saying, oh, well, I know 25 goes into 100 4 times, but 4 times 24 is not going to give me 100. I think that's only going to give me 96. So what can I do here? you can go through this process. So you can reduce the fraction and then try and make this a fraction with a denominator of 100 if the numbers are more compatible. So that's another strategy you can try if you come across problems like this. Okay, so what we're going to do is we're also going to be talking about fractions that are greater than 100. And these are, let's see, which tool should I use? I'll use this one. So if I had a number like 250 over 100, if I had a fraction like this, we all know from our work in fractions that you guys have been doing for several years now, you know that this is an improper fraction, which means the value of this fraction is greater than 1 because our numerator is greater than the denominator. So because our numerator is greater than the denominator, we know that the value of this fraction is greater than 1. So this fraction must be at least 1 and something. And here's a trick we can do. Whenever we have fractions like this where we have the numerator and the denominator that both end in a 0, so this 250 ends in a 0, this 100 ends in a 0, what I can do is I can actually I can cancel out these two zeros, because what I'm really doing is dividing both the numerator and the denominator by 10, right? If these numbers both end in a 0, that means they're both divisible by 10 by my divisibility rules, which means if I divide them both by 10, I'm going to eliminate that 0 on the end. So now I have an equivalent fraction that's in lower terms. This is not in lowest terms, right? We still have a common factor of 5. So we could make this 5 over 2 if we divided both by 5, the numerator and the denominator. But for now, we can leave it this way. So if we have 25 over 10, we've just divided both the numerator and the denominator by 10 to make an equivalent fraction that's in a lower terms. This is still going to represent more than 1. So this would be if we have, we'll use our fraction logic. So how many times does 10 go into 25? Well, 10 goes into 25. Let me change this color back. 10 goes into 25 twice, right? With how many left over? So if we have 25 tenths and we pull out 20 tenths to make 2, how many do we have left over? We're going to have 5 tenths left over, right? So we pull out 20 tenths to make 2. We're going to have 5 tenths left over, so that gives us 2 and 5 tenths. We know, of course, that we can write an equivalent fraction there. We can make an equivalent fraction that's in lowest terms here, and we could have 2 and 1/2 would be this fraction in lowest terms. Okay, so just again, this is just a reminder on how we can manipulate fractions. So we started with this 250 over 100. So 250 over 100, just as a reminder, this would represent 250%. So 250 over 100, we would say, that represented 250%. So we are going to be talking about percents that are greater than 100 during this lesson. And I was just giving you a little bit of a rundown on how you can move from this 250%, what does that mean? What's percent greater than 100? Well, you can think of a percent greater than 100 as like an improper fraction, because a percent greater than 100 just means that that number, 250, is your numerator, is your first term, right, in this fraction that's going to have a denominator of 100. So it means whenever you have a percent that's higher than 100%, you can just think of that as an improper fraction. It's going to have a value of greater than 1. Okay, so if we reduce this fraction 250 over 100, first we divided by 10. We wrote it as a mixed number, 2 and 5 tenths. We wrote this mixed number in lowest terms, so now instead of 2 and 5 tenths, we have 2.5. So 250% equals 2.5. Okay, so now we're going to move on to our lesson. I just wanted to give you guys a brief overview. Okay, so what I'm going to have you do today is I'm going to have you work primarily on solving this first problem. Okay, so the way I'm going to break these lessons up is we're going to do an intro lesson, we're going to do the warm-up problem together, and then I think on the second day, I'm going to have you guys move through the examples with me and do the practice problems. So I'm going to structure the way I break the lesson in half a little bit differently this week, just based on feedback and what I noticed from last week. Okay, so this question asks us, and again, you should have your workbook in front of you and you should be on page 347. Okay, so this question asks us, Marcy, Bobby, and Max began their homework at the same time. Marcy finished her homework in 60 minutes. Bobby finished his homework in 50% of the time it took Marcy to finish. Max finished his homework in 150% of Marcy's time. How long did each of them work? Okay, so I want you to pause the video now. I want you to take a second to try and solve this problem. You can model this problem using the tools that we explored in the last two lessons, hundredths grids, number lines, circle graphs. Just find a way to explore this problem that works for you. Okay, so I want you to pause the video, try it out, and then come back for the answer. Friends, I have chosen to represent this problem using number lines. So I have a number line for Marcy, for Bobby, and for Max. I plotted 60 minutes here as 100%. I knew that half of 100% equals 50%, which is the amount of time that Bobby spent on his homework. So 50% of 60 minutes is going to be half of 60 minutes. So 50% of 60 minutes would be equivalent to 30 minutes. Now I know that 100% is 2/3 of 150%, right? So if I think of 100% as being broken into groups of 50, so I have two groups of 50. And if each group of 50% equals 30 minutes, that means 150% is three groups of 30 minutes. So 30 minutes, 60 minutes, 90 minutes. So that's what I've written down here. 90 minutes would be equivalent to 150%. So the amount of time that Max spends on his homework would be equivalent to 150%. And I did write this little series of fractions up here because I wanted to stress to you guys, I can write this. I could solve this whole problem just using equivalent fractions. So if I'm saying I have 60 minutes equals 100%, I can just write equivalent fractions for any other percentage by changing the denominator to the fraction, to the percent that I want to represent. So if I know that 60 over 100, so 60 minutes per 100%, right? I can figure out, okay, I'm going to divide my numerator and my denominator both by 2 in order to calculate the number of minutes for 50%. Okay, so now I can go to get from 100% to 150%, I'm going to multiply by 1.5 to get from here to here. Okay, I can also multiply my numerator by 1.5 to calculate the number of minutes that will be representative of 150%. Okay, so I can also use this equivalent fraction strategy, which is really your rate reasoning from topic 5, to calculate rates. If I know what the rate is, if I know what the first term of the rate is out of 100, I can use this strategy to calculate other percents. So that's all we're going to be doing on this lesson for today. Okay, I want you guys to check your Google Classroom for your other assignments, and we'll finish the second half of this tomorrow. Okay, so you'll find that on your Google Classroom tomorrow. All right, thanks for listening, guys. Have a great day.